My name is Professor David Gomez Barquero. I'm the project coordinator of FUDGE-5G, which is a research project here in Europe that focuses on customized cloud-native 5G private networks. The main motivation for the project was that 5G private networks will require customized solutions because the number of industry verticals is huge, and each will have different requirements, and therefore it's very important to be, there will not be a single 5G private network that capable of meeting all the requirements. And we also, as I said, we focus on virtualized and cloud native private networks. Well, the project started recently, last September. It will run for 30 months. And in this presentation, I will focus on the 5 use cases that we intend to demonstrate and all the novelties that we will bring. Here you have the consortium. It's a mix of, on one side, high-tech SMEs, all bringing different 5G components. We have large 5G vendors as well. Mobile operator, Telenor from Norway, because all the use cases will be demonstrated there on top of the 5G Vini experimentation platform, and well, also some research institutes like Fraunhofer Focus and well, the Technical University of Valencia, where I belong. Here you have like a list of the main technical innovations. I will explain them later. But well, to mention just a few, we are working towards a unified service-based architecture, meaning that we also want to include within the SVA the user data plane, not only the control plane. We are also working towards developing 5G core network functions as microservices that can be deployed either at the edge or in the cloud, or as well on premise. A very important feature for private networks will be the LAN native support, meaning that you can combine like a fixed LAN with Wi-Fi and 5G into what we call an all Ethernet access. And well, you have there the complete list. We'll mention well some synchronization aspects, and we will also address the interconnection of non-public networks with public networks and different setups. Here you have the high-level architecture. And well, basically, yes, this is a way to highlight also the innovation. So we will have some innovative features for the user plane, including these cloud native 5G core network functions. The project also tackles service routing and resource scheduling for the 5G core network functions and related traffic. The all Ethernet access, having like different technologies and being transparent from the users or devices. I will present you 5 use cases, each with a stakeholder, which is the final end user. The project, we will also work on orchestration and lifecycle management of the virtualized resources, and well, also addressing the infrastructure as a service. This is the ongoing work regarding the platform architecture that we are designing currently, and later on we will develop. Here the innovations are at a more detailed technical level, but I will go through this, and I think in this I will focus more on the use cases. But well, there you can see basically the innovations I have already discussed, but maybe with a more detailed information from a architecture point of view. So, for example, here you have the 5G LAN, the 5G TSM for synchronization, opportunistic multicast, the orchestration and lifecycle management, and well, from the verticals applications. So regarding the 5 use cases, in all of them we have a stakeholder. For the media use case, we have the Norwegian Public Broadcasters, NRK. And well, as you can see here, we have like a private network where we have on one side live television content production. In this part, we will test innovative new radio features. So for example, super uplink or bandwidth parts. And then we will have what we call a media showroom, which is well, a place with a lot of users, and where we will demonstrate, for example, opportunistic multicast in addition to this 5G LAN functionality. In this use case, for example, we will make a multi-vendor setup where the control plane is on the cloud and the user plane on the premise, and with different 5GC vendors. And we will also test different deployment options for like a hybrid or cloud premises deployment. Regarding we have another use case is on PPDR. And the stakeholder is the Norwegian Defense Materiel Agency. And what we aim here is to build a non-public 5G network, which is transported in a vehicle. And this network works even when there is no other infrastructure available. This one of the main characteristics is that it will be easy to deploy and fast to configure. And as I was saying before, it should also work in a standalone. We are calling this autonomous edge. And well, being a PPDR use case here, everything related to security, it's of course very important. And as I explained before, we will also address the possibility of connecting this private 5G network with the public network and keeping all the security and reliability constraints of the stakeholder. We have our third use case. We call it hospital virtual office use case. We are talking a lot about the future 5G virtual offices, which will be enabled by either private networks combined with 5G LAN, having this unified all Ethernet access. And in the project, what we are focusing on for this specific use case is to apply it to a hospital. So the idea is that in the hospital there is a private network. It provides isolation for all the information and devices, but in this case there will be some interconnection of the private network with the public network in order to reach coverage outside the hospital, for example, and even to reach for example, ambulances that are in the city and are outside the reach of the private network. So in this case, the main innovations are, well, the use case is built around this all Ethernet access concept, and then as well security aspects. So this interconnection between the public network and the private network can be done keeping well, all the security and constraints. The stakeholder is, in this case, the Oslo University Hospital. Our fourth use case is on Industry 4.0. Here, the stakeholder is ABB, and this use case is progressing a bit slower because there was actually a change in the stakeholder. So basically, the ideas we have is to showcase 5G TSM. You know, this protocol for timing and synchronization, and another of the new features will be a new and a specific developed 5G gateway or modem for industrial applications. And our fifth and final use case, we call it 5G EduRAM. Maybe some of you you are not familiar with EduRAM. It's like a network among all the, well, not all, many universities, not only in Europe, but also worldwide. And for example, if I go to another university abroad that belongs to EduRAM, I can log in using my credentials from my own university. So in this use case, what we plan to do is to interconnect 3 private networks in different countries. One in Berlin, in the campus of Fraunhofer Focus Research Institute, another one in Telenor in Norway, and also the third one will be here in Valencia in Spain. So currently the 3GPP specs do not specify how private networks should be interconnected. And so that will be one of the main innovations in this use case. And it's also a use case built around this 5G LAN and all Ethernet access paradigm. But here it will be also very important, the distributed authentication framework, so that we basically replicate or the authentication mechanism of EduRAM, so that you can actually go to a different private network and interconnect or log in with your own credentials. So it's not exactly roaming, but well, there is some difference. And well, that's it from my side. I have many technical details that I have skipped, but well, if you have any question later on, I'm happy to answer them. And if not, well, in the public webpage of the project, you will find all the information.